Hello students, today we will solve some numericals based on partial derivatives, but before that let's discuss what is partial differentiation and how it's different from the basic differentiation that we have already studied. Consider there is a variable z which is a function of x, that is the variable z is dependent on variable x. Then, in order to calculate rate of change in z with respect to x, we use the term dz by dx. That is, dz by dx represents change in z with respect to change in x, and it's also known as derivative of z with respect to x. But now let us consider a second scenario in which the variable z is now function of x and y. That is, z is dependent on two variables x and y. X and y are independent variables and the variable z is dependent. Now in order to calculate change in z, we need to consider both x and the variable y. अगर हमें z में चेंज को कैलकुलेट करना है, अब जो z है x और y दोनों पे डिपेंड कर रहा है, तो दोनों के चेंज होने से z की वैल्यू में क्या होगा, चेंज आएगा, which will be represented by dz. dz क्या रिप्रेजेंट कर रहा है, here dz is representing total change in z. If I write like this, dz by dx, now what does it represent? Total change in z with respect to variable x. And if I write dz by dy, what does it mean? Total change in z with respect to y. Now in order to calculate the total change in z, we need to calculate first the partial change in z with respect to x and y. And what are these terms? The symbolical representation is curl z by curl x. And what does it represent? It represents partial change in z with respect to x keeping y constant. That is what we are doing. We will keep y constant. Y is considered as a constant now, and we will calculate that how much there is change in z with respect to change in x. कि जब x चेंज होगा, x के चेंज होने से z में कितना चेंज हो रहा है, और उस टाइम पे हमने y को क्या रखा हुआ है, कांस्टेंट रखा हुआ है, then that term is known as curl z by curl x, partial derivative of z with respect to x. Similarly, what will be curl z by curl y? Curl z by curl y means partial change in z with respect to y, and we will keep x constant. And so let's start with the first example, which is if u is equals to x square y minus z plus y square z minus x plus z square x minus y, we have to prove curl u by curl x plus curl u by curl y plus curl u by curl z is equals to 0. So we are given a function u which is dependent on three variables x, y and z, and we need to prove the given equation. जो हमें दे रखा है लेफ्ट साइड में इक्वेशन को हम उसे सॉल्व करेंगे एंड वी विल प्रूव दैट इक्वल्स टू राइट हैंड साइड, दैट इज 0. So here, before starting the solution, let's have a look at the formulas first which we are going to use in this problem. See, the formulas of differentiation, whether it's the total differentiation or partial differentiation, the formulas remain same. The only difference is the symbol that we are going to use to represent them. For example, the derivative of x raised to power n, as you all know, it's n x raised to power n minus 1. But when we are doing partial differentiation, then there will be more than one independent variables, like it can be x, y, z. So I will write curl by curl x because we need to mention that we are differentiating the case in which the number of independent variables is more than 1. So the formula will be still same, n x raised to power n minus 1, but during partial differentiation I will be using the symbol curl instead of d. For example, the derivative of a constant is 0, then derivative of a function something like c into f of x, that is a constant multiplied with some other function, then it's not going to be 0. See, if the constant is alone there, then its differentiation will be 0. Like if you all know what is derivative, derivative measures the change, and if something is already constant, what will be change in that value? That will be simply 0. But when the constant is multiplied with some another function, then you can't say that differentiation will be 0. Rather, what we do, we keep the constant outside and the differentiation is done for the given function. These are the formulas which will be required to solve the given problem. Now let's have a look at the solution of that problem. We are given this function u, let's mark that equation number 1. Now if you see, according to question, I need 3 terms: partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. Now let's calculate them one by one. So differentiate equation 1 partially with respect to all of the variables, what you will get? Curl u by curl x. Now when you are differentiating this u function with respect to x, what I told you in the last lecture, that y and z will be considered as constant. अगर आप x के साथ डेरिवेटिव कर रहे हो उस टाइम पे y और z दोनों ही क्या हो जाएंगे? कांस्टेंट हो जाएंगे. Now let's have a look at the differentiation. Now this y and z constant, let it be. And what is derivative of x square? Power rule of differentiation, 2 into x. Then plus y square constant as it is, z constant, derivative 0 minus 1. See, now this is the confusing point which may confuse you. Let me elaborate it again. We have this term y square z minus x, and what we are doing here, we are going to differentiate it partially, obviously, with respect to x. Now I told you the condition that if your constant is alone, this will give you answer 0, but if your constant is multiplied with some function, then it can be considered as c derivative of f of x. Now here if you see, we are differentiating with respect to x, and this y square is multiplied with some term of x. Now यहाँ पे y square अकेला नहीं है, this is in multiplication, so this will be y square. Now here z is alone here, यहाँ पे z अकेला ही बैठा है, z के साथ कोई नहीं है x की टर्म, सो z का डेरिवेटिव यहाँ पे क्या हो जाएगा? 0, एंड डेरिवेटिव ऑफ x 1. इफ़ इट वुड हैव बीन लाइक दिस, अगर ये कुछ इस तरह से होता, जैसे मान के चलो zx माइनस एक्स, लेट्स से दिस वाज द इक्वेशन, देन अब यहाँ पे क्या होता है? अब यहाँ पे देखो zx के साथ मल्टीप्लिकेशन में है, z को एक सहारा मिल गया, z इज with x. Here I will not say the derivative of z is 0. Here z is a constant, derivative of x is 1 minus 1. इस तरह से होना था. I hope this part is clear to everyone. When the constant is alone there, the derivative will be 0, but when the constant is multiplied with some function, then that constant is taken outside and we do the differentiation of that function. यहाँ पर y square जो था वो multiplication में है x की टर्म के साथ, तो y square 0 नहीं होगा, बट जो z फंक्शन था, z वेरिएबल था, वो अकेला यहाँ पे बैठा हुआ था, जिस वजह से उसका डेरिवेटिव क्या हो गया है? 0. Now going to the next term, again it's z square constant as it is, derivative of x is 1 and derivative of y is 0. So I calculated curl u by curl x. Now let's do the little bit of simplification. Brackets को open कर देंगे and we will get our first equation. Similarly we will solve curl u by curl y, as you can see here. X square constant, derivative of y 1, derivative of z 0. This is what I wrote here. Then y square into z minus x, derivative of y square 2y, z is a constant, so derivative of z will be, now here z and x both are constant, so it's z minus x, plus then z square constant, derivative of x 0, derivative of y is 1. We got the equation 2. Similarly you can have the equation number 3. Once you are done with all the 3 equations of differentiation, we will consider the left hand side. which was curl u by curl x plus curl u by curl y plus curl u by curl. So left hand side is curl u by curl x plus curl u by curl y plus curl u by curl z. Substitute all the values here. Considering all the values, you will see the terms are getting cancelled out here. You can do this calculation. You will see the 2xy is getting cancelled out here with minus 2yx. Like that, all the terms will get cancelled out and you will get the answer 0, which was required to prove. Moving to the second example, we have a function u which is dependent on the variable r. U is a function of r, where further r is expressed in terms of x and y. That is, the variable r is dependent on variables x and y. If you look at the flow chart, see, u is dependent on the variable r, and further r is dependent on two variables x and y. So we can say indirectly u is dependent on x and y. So if x and y are going to change, they will lead to ultimately the change in u. Now in the numerical, we need to prove this equation which is mentioned here, that curl u by curl square u by curl x square. And what does it represent? Second order derivative of u with respect to x plus second order derivative u with respect to y as f double derivative f double dash, which is double derivative of f with respect to r plus 1 by r f dash r. This represent derivative of f with respect to r, and this term is representing the first term, second order derivative of f with respect to r. So we need to prove this equation. Now given u is some function of r, that is exact value is not given here, we are just given that u is some function of r. हमें properly function ही define कर रखा है, जैसे हमें ये function दे देते that u is equals to cos of r. But instead of giving that function, they are just simply mentioning that u is f of r, and equation number 2, r square is x square plus y square. Now from equation 2, if I differentiate this partially with respect to x, what I will get here? Derivative of r square will be 2r curl r by curl x, and derivative of x square is 2x. Since y is a constant during differentiation with respect to x, so it will be 0, like this, 2x plus 0, which will again give me 2x. Similarly, differentiating this equation 2 with respect to y, what I will get here? 2r curl r upon curl y is equals to 2y. Cancelling 2 both sides and shifting this r to right side, I will get the value of curl r by curl x as x by r, and value of curl r by curl y as y upon r. Now moving to main equation, you see I need derivative of u with respect to x of order 2. Let's first differentiate it once. Differentiating equation number 1 with respect to x partially, what you will get here? Curl u by curl x. First equation का derivative करना है अभी हमने. It will be curl u by curl x. Now derivative of f of r will be f dash r into curl r by curl x. See what we are using here. Here we are using the chain rule. See, if you recall, whenever we were solving some formulas for the functions, y is equals to sine 2x. This is a common function which we have already solved the differentiation, for which dy by dx is how you solve this. If you recall, derivative of sine is cos 2x, then again in the next step we do the differentiation of that angle. Remember, ऐसे ही होता था. अगर हमें कोई इस तरह से फंक्शन दे रखा है sin 2x, तो क्या होगा? पहले हम साइन का डेरिवेटिव करेंगे cos 2x, फिर उसके साथ हम चेन बनाएंगे उस एंगल का डेरिवेटिव करने के लिए 2x का डेरिवेटिव हमारे पास हो जाता था 2, तो हमारे पास आ गया 2 टाइम्स ऑफ cos 2x. सेम थिंग इज हैपनिंग हियर. सी, u इज f ऑफ r. u की वैल्यू क्या है? कुछ r के टर्म्स में होगी, एंड वी डोंट नो व्हाट इज दैट एग्जैक्ट फंक्शन. एंड फर्दर r इज एक्सप्रेस्ड इन टर्म्स ऑफ x एंड y. r की वैल्यू आगे किस में दे रखी है? x और y में. सो व्हेन यू विल डिफरेंशिएट डेरिवेटिव of u with respect to x, तो क्या होगा? First we will differentiate this function, so f dash r, like I wrote for sine, I know the answer, it's cos, and the angle will still remain same. See, cos 2x, it was sine 2x, I only did the derivative of sine, which is cos, and the angle still remains same.
Same thing is happening here. I did the derivative of f, which is f dash, and the angle r remains same. Now I need to do the differentiation of this angle, na? So I will write curl r by curl x. Similarly, if you need to calculate curl u by curl y, but it will be derivative of f dash, still the angle will remain same. Now the second term is of this angle, curl r upon curl y, in this way. Got it? Now continue, let's continue the problem. So I got curl u by curl x is f dash r, curl r by curl x. Now put the value of curl r by curl x from here, which was x by r. So I put that value here, f dash r into x upon r. Just shifting the brackets, I can write it like x into f dash r upon r. So what I did is just rearrangement of the terms. X को आगे लिख दिए, f dash r upon r. So I got the value for curl u by curl x. Now I need to calculate second order derivative. So I will differentiate this again with respect to x. So it becomes curl square u by curl x square, derivative of this term x into f dash r upon r. Here you have two terms. Now some of you might be considering that why we are using product rule here, since we are differentiating with respect to x. See, here the symbol r is also a variable which is dependent on x and y. So remember that. See, when you are differentiating partially with respect to x, that time y is constant, no doubt, but the function r, the variable r is dependent on x. So you can't say r is constant for x, rather r is the variable which is dependent on x. आर की वैल्यू एक्स के ऊपर डिपेंड कर रही है, आर कांस्टेंट नहीं हो सकता है. तो जब आप एक्स के साथ डिफरेंशिएट कर रहे हो तो यहाँ पे ये दो फंक्शंस हो गए. एक तो खुद एक्स है ही, एक ये जो हमने एफ ऑफ आर लिख रखा है ये भी इनडायरेक्टली किसका फंक्शन है, एक्स का ही फंक्शन है, तो इसका भी डेरिवेटिव होगा. एंड वेन एवर वी हैव मल्टीप्लिकेशन ऑफ टू फंक्शंस देन वी ऑलवेज यूज दी व्हाट वी यूज, प्रोडक्ट रूल. लेट्स अप्लाई दैट. First function as it is derivative of second function plus second function as it is derivative of first function. Now if you look closely here, this term is f dash r upon r. So again, to do its differentiation I need to use what here, quotient rule. Yes, so we need to apply quotient rule here. I hope you all know what is the formula for quotient rule. If not, let me write it here. Derivative of u upon v. So the formula is v as it is derivative of u minus u as it is derivative of v upon v square. This is the formula for quotient rule, and this is what I am going to use here for f dash r upon r, and I am differentiating with respect to x, remember that. So second function as it is r, derivative of first function. Now see, what is the first function here, f dash, and I am going to differentiate it again. So it will become f double dash r into curl r by curl x. Again the chain rule, remember derivative of f dash is f double dash, but the angle r is still same. Now I need to do the differentiation of this angle, and differentiation of this angle r is curl r by curl x. Then put a negative sign according to the formula. Second function is derivative, that is derivative of r. Now f dash r as it is, and डेरिवेटिव ऑफ आर इज, नाउ व्हाट इज डेरिवेटिव ऑफ आर, आर का डेरिवेटिव क्या होगा, 1 इंटू कर्ल आर बाय कर्ल एक्स, और यू कैन सिंपली से द डेरिवेटिव ऑफ आर इज कर्ल आर बाय कर्ल एक्स अपॉन आर स्क्वायर प्लस, नाउ दिस इज डन, एफ डैश आर and derivative of x is simply 1, so f dash r into 1. Now I will put the value here. Now this is x, I can take curl r by curl x common, so I got this equation. Now moving further, x, this is r square, I can write it here like this, r f double dash r minus f dash r. And what was the value of curl r by curl x, if you recall, this was x upon r into x upon r plus f dash r. This is x upon r square and this is x upon r, so I got x square upon r cube r f double dash r minus f dash r plus f dash r. This is curl square u by curl x square. Similarly, you can write curl square u by curl y square by observing the pattern. In the same way, you will calculate the double derivative with respect to y. What that it will be? Instead of x, it will be y square upon r cube r f double dash r minus f dash r plus f dash r. Now, as per the question, the left hand side was curl square u by curl x square plus curl square u by curl y square. So, considering left hand side, curl square u by curl x square plus curl square u by curl y square, we get x square. Substituting the values now, simply this plus f dash r plus for y it was y square upon r cube r f double dash r minus f dash r plus f dash r. It might be looking little bit confusing to you, but when you're going to solve this by yourself na, you will get much clarity. Now see, look at the first term and the third term. The bracket which was r f double dash r minus f dash r, this can be taken out common, so I'm going to write it like this, and what's left inside. And also see, we can also take r cube common, so inside I am left with x square plus y square, and the second term and the fourth term, they gives me 2 times of f dash r. Now this is r f double dash r minus f dash r upon r cube, and what is the value of x square plus y square? Recall, in the beginning it was given to be r square. So this is r cube and this is r square. Cancelling, I got 1 r here. So r f double dash r minus f dash r upon r plus 2 times. So this is all the calculation, and you can do the calculation as per your convenience. So this is 1 by r f dash r plus 2. Wait. Something is missing here. 1 second. The value, yeah, this is what we missed here is, this was second function. When I wrote the second function, we missed the value r here. See, second function was f dash r upon r. This r was missed here. So basically this is r here everywhere. So what we got, this is upon r and like this, yeah, f double dash r. Now this is minus 1 by r f dash r plus 2 times of f dash r, and this was our right hand side, and we have proved that, hence proved. Now coming to next example, we have theta is equals to t raised to power n e raised to power minus r square upon 4t if 1 by r square curl by curl r square curl theta by curl r is equals to curl theta by curl t. Find the value of n. So here what's happening, there is a variable theta dependent on two variables t and r, and it's already given that the equation is satisfied by theta. ये लेफ्ट हैंड साइड राइट हैंड साइड इक्वल है, ऑलरेडी हमें दे रखा है, एंड वी नीड टू कैलकुलेट द वैल्यू ऑफ दिस अननोन कांस्टेंट n. So first we will solve left hand side, then we will solve right hand side. We will equate them, and from there, by comparing those two sides, we can have the value of n. Theta is t raised to power n e raised to power minus r square upon 4t. Let's mark this equation number 1. Now let's solve left hand side first. So I am going to differentiate it partially with respect to r. सबसे पहले r के साथ डेरिवेटिव करते हैं. Now since you are differentiating with respect to r, it means at that time t raised to power n is constant. Let it be. Now what is derivative of exponential function? That is derivative of, if we talk about what is derivative of e raised to power fx, it is e raised to power fx along with that derivative of that angle fx. The same thing like I told you, एक्सपोनेंशियल का डेरिवेटिव क्या होता है, सेम रहता है, लेकिन साथ में जो वो पावर है उसकी एंगल है उसका भी दोबारा करना हो. सेम विल बी हैपनिंग हियर. सो डेरिवेटिव ऑफ ई विल बी फर्स्ट ई रेज टू पावर माइनस आर स्क्वायर बाय 40 along with that derivative of this angle. Now minus derivative of r square will be 2r
and 40 is constant, so it will remain like this. Simplifying, what you get here, minus, see this is t raised to power n, and what is here, t, so this will be t raised to power n minus 1. This is 2 upon 4, that is 2 r e raised to power minus r square upon 4t. This is my curl theta by curl r. Just focus on left hand side, and whatever they are asking for, we will do that thing step by step. Now we have to multiply by r square. So multiplying both sides by r square, we will get minus t raised to n minus 1 upon 2. It was already r there, it will become r cube, then exponential function. Now what the next thing they are asking for, curl by curl r, again differentiation with respect to r. So let's do that. See, this is constant, keep that aside. Now these are two functions, so we have to use product rule. First function as it is, r cube, derivative of second function, that is derivative of that e. So in the bracket minus 2r upon 40, just in a similar way, plus second function as it is, derivative of first function, and derivative of first function r cube will be 3r square. Now we will simplify these terms. You can see from the bracket we can take e raised to minus r square by 40 common, so I'm going to take that outside, minus t raised to n minus 1 upon 2 e raised to minus r square upon 40, I took it outside. This is r cube, this is r, so I can write it minus r raised to power 4 upon 2t. This 2 and 4 they are cancelling, plus 3r square. This is what I got. Now if you look at the problem, next step is to divide the value by r square. So dividing this equation by r square, what we will get, minus t raised to n minus 1 upon 2 e raised to minus r square upon 40. If I am going to divide this by r square, this will be minus r square upon 2t plus 3 r square के साथ हमने divide कर दिया ना. So I am done with my left hand side. Let's say this is my equation number 1. Now what's the right hand side? Right hand side is curl theta by curl t, that is derivative of this function now with respect to t. I'm just rewriting the value of theta again. It's not required, I'm just showing this to you only. Curl theta by curl t. Now see again, here we have two terms of t now, first and second. So we need to use product rule. First function as it is, t raised to power n, derivative of e, exponential, same. Then the derivative of angle. Now remember r is constant and we are differentiating with respect to t. Don't get confused. It's simply minus r square upon 4, and derivative of 1 by t is minus 1 by t square. 1 by t का डेरिवेटिव यही होगा ना, minus 1 by t square. That is what I am writing here, plus second term as it is, derivative first, that is t raised to power n. The derivative is n, t raised to power n minus 1. Again, just to simplify this, you can see I can take this exponential common. So what I will get here, I am taking e raised to power minus r square by 40 common. Now this is minus and minus plus r square upon में 4. This was t raised to power n, in denominator it was t square, n and t square, n minus 2 plus n t raised to n minus 1. This is my equation number 2. Let's equate number 1 and number 2 according to the question. Left hand side is given to us equals to right hand side. So what we get, e raised to power minus r square upon 4t, it was minus t raised to n minus 1 upon 2. So after substituting the values, we come here, this is getting cancelled out, and multiply this t raised to n minus 1 and 2 factor inside. So what I will get here, negative and negative positive, r raised to power 4. So this is r square, 2 and 2 will become 4, t raised to power, it's already n minus 1,
1 t is in the denominator, n minus 2 plus, sorry, this will be changed to minus 3 t raised to n minus 1 upon 2 equals to r square upon 4 t raised to n minus 1 plus 3 n t n minus 1. Again this term is getting cancelled out. So what we get here, minus 3 by 2 t raised to n minus 1 and t raised to n minus 1, t raised to n minus 1 cancel. So the value of n is, after comparison, we get minus 3 by 2, and this is our final answer. Got it? Now let's look for the next example. U is equals to x square plus y square plus z square raised to power minus 1 by 2, and we have to prove this second order equation to be equals to 0. Given u is equals to that function, let's mark it number 1. First I will differentiate this with respect to x. Curl u by curl x. So what we are going to use here? First, power rule. Minus 1 by 2 x square y square z square raised to power minus 1 by 2 minus 1, that is minus 3 by 2. ये होता है ना पावर रूल. अगर हमारे पास f of x है raised to power n, then the derivative is n fx raised to power n minus 1. Along with that, again remember the derivative of that function f of x. Same I am going to apply here. Power outside, subtract 1 from the power. Now derivative of this inside term, derivative of x square 2x, derivative of y square and z square will be 0, because we are differentiating with respect to x, and at that time both y and z are considered to be constant. Simplifying, cancelling 2 minus x into x square y square z square raised to power minus 3 by 2. So this was my first order derivative. Now I will differentiate this again to get curl square u by curl x square. Now I need to apply product rule here. First function, second function. First function as it is, derivative of second, that is minus 3 by 2. Again the power rule, x square y square z square minus 3 by 2 minus 1, that is minus 5 by 2. Then again derivative of this angle x square 2x, right, plus second term as it is x square y square z square raised to power minus 3 by 2, derivative of first function, that is this x, which will be simply 1. Now we are going to simplify this equation. See, this 2 is getting cancelled out. I will take this negative inside, and I am going to take common this term, x square plus y square plus z square minus 3 by 2. Usually we take the lowest powers common na. If you look, the minus 5 by 2 term is the should be taken out common, but it's nothing to be incorrect here. You can either take the power minus 5 by 2 common, or you can take the term minus 3 by 2 common. Ultimately you are going to have the same result, same destination. किसी को भी common निकाल सकते हो. So I am going to take minus 3 by 2 power common. So what's left inside? Now this negative is coming here, so this negative and negative will become positive. 3x into this x square. Out of minus 5 by 2, I took minus 3 by 2 common. So how much is left? From 5 by 2, I took minus 3 by 2 common. How much power is left? Minus 1. If you are finding it difficult, na, simply what you have to do, what was the total value? Minus 5 by 2. How much you took common? Minus 3 by 2. Subtract them. Minus 5 by 2 plus 3 by 2 minus 2 by 2 minus 1. This is, if you find it difficult, na, this is how you can look at this. Plus, simply not plus, we are taking negative inside na, so it's minus 1. So this is my second order derivative with respect to x. Similarly, you can calculate curl square u by curl y square. How? First by differentiating with respect to y, then getting an answer, then again differentiating that. I am going to write this answer directly by observing the pattern. So what's the pattern here? X square y square z square raised to power minus 3 by 2 into 3, instead of x square, but it will be y square. Just replace the term of x square by y square plus minus 1. Similarly, you will solve for curl square u by curl z square. You will get the answer here. Now as per the left hand side we need to add them. Curl square u by curl x square, then y, and then z. Let's put the values one by one. X square, y square, z square, minus 3 by 2, 3x square, x square, y square, z square, minus 1. I'm just substituting the values. Then plus 3y square, simplifying. What you get here is, now look at this term, first, then third, and this fifth term. 3 can be taken common, and this term x square, y square, z square is to power minus 1. This is common. So what's left inside the bracket? This x square, this y square, and this z square. Now minus 1, minus 1, minus 1, minus 3. We are just 2 steps away to get the answer. X square, y square, z square, power 1, minus 1 and power 1. So they are simply cancelling each other. So it's simply 3 minus 3, that is 0, and which was required to prove. This is our right hand side. So this was all about how to solve the numericals of partial differentiation. Still, if you have some doubt, you can let me know. We can cover that in our next video. Thank you.